Hello everyone, and welcome back to another video in the 3D printing corner. And what you can see right here is, as the sign says, the Creality Ender-3 CMD-Edition. This is the exact same Ender-3 that I made a video about a short while ago, and it has now been heavily upgraded. There is like more than half of the printer has been replaced. Really the only thing that still remains is the frame. Basically everything else is new. And yeah, I thought I was gonna make a video about this because this printer it's actually starting to rival my Ender-5. It's not quite as fast. The accelerations this thing is capable of are about half as high as what the Ender-5 can do, but that doesn't mean that those accelerations are low. So yeah, let's get into all the upgrades I've done. Now the printer is currently printing. As you can see, it is actually printing in ColorFab lightweight PLA right now, and it's making a 50% scale model of my F111CS, which I intend to use for some aerodynamic testing, possibly towing it behind another plane just to see, how it flies, and potentially making one that actually can fly, because I found out they do make 30mm EDFs, which run on 3S batteries, which all would fit in a 50% scale of this. But more on that in a different video if I decide to do that. Let's talk about the printer. I think it's best to just go through all the upgrades I did chronologically, because there are so many of these, except for the ones where I have to stop the printer to show you, because I have upgraded the wiring as well. So yeah. So, the first thing that I upgraded on this printer is something quite simple, and it is the print bed. If you look at the print bed right now, you see it's this sort of like gold, shiny print bed, and it is also magnetic. The old print bed wasn't. The old print bed was a very slightly flexible but mostly rigid, I think, glass fiber print bed with this black, like, polycarbonate surface, and it was just, it was fine. But I much prefer a PEI print bed. As you can see, my Ender-5S1 also got one, though it did get a proper Creality one. This is just the cheapest one I found on Amazon that fits the Ender-3, because the Ender-3 doesn't come with these two end stops in the print bed that help you line up the print bed. Like you can see at the back, it doesn't have these. So yeah, there was no benefit in getting a proper Creality one for this, so I just took the cheapest. But yeah, the print bed is now magnetic. It is no longer being held on by clips, and it is also, a lot more flexible, so you can get prints off it easier. And just generally, I like these PEI surfaces just kind of better than the polycarbonate ones. So that's the first upgrade. Quite simple though, this wasn't really needed, that was just personal preference for me. So what's the second thing I did? Well, the second thing I did is actually something that I would have to stop the printer for, so we'll get into that later, but you can see that this Sonic pad right here is currently controlling the Ender-3. Now the Sonic pad thinks it's an Ender-3 V2 ABL. It's not, it's still an original Ender-3. The cover somewhat goes over the sticker, but you can see 2018 is the manufacturing date right there, so this is not an Ender-3 V2. It's just an Ender-3. But yeah, I did upgrade the control board in it. I no longer have the stock 8-bit board in it. It has a 32-bit board in it that was scavenged out of an Ender-3 V2, which is why the Sonic pad thinks it is one, because I needed to use compatible firmware. But we'll get into that a bit later, because I need to open up the motherboard case for that, and since the printer's running right now, let's not do that right now. Then, the third upgrade, and this was, and still is, the most important upgrade that you should do to any Ender-3 that doesn't come with it. Seriously. It is this little unassuming looking probe. This is a 3D Touch, which is a knockoff of a BL Touch. And, well, this is an auto bed leveling probe. You can see my Ender-5 also has one. It's a bit hidden under there, but you can see this tiny pin on the backside. This is a CR Touch, which is Creality's knockoff of a BL Touch, but it's effectively the same thing. It has this little sensing probe, which extends downwards, and it just senses the level of the print bed. And I've actually set this printer up to do 64 individual tests, so it goes in an 8x8 grid pattern, and then senses, you know, where are high spots, where are low spots on the print bed, and then it can compensate for that when printing. So you don't need to, you know, use these springs and wheels to like make the bed super level, because, you know, they do loosen over time, and you can always have a little bit of residue left on the print bed or under the print bed. So I've solved this by just adding G29 to my start G code, which causes the printer to do a full bed leveling procedure before every print. Yeah, that adds like 2 to 3 minutes to every print, but you know, this 50% nose section of the F111 still takes a couple hours, so 2 to 3 minutes, I don't really care about that. And the benefit is you just kind of can forget about bed leveling. The printer just does it itself with this little probe. And this probe is also the main reason I upgraded the control board. Having the 32-bit CPU is nice, but the 8-bit CPU would have been enough. Like, I am using the Sonic pad, which does most of the processing for the printer, so the CPU in the printer doesn't really matter that much. But the 8-bit control boards for the Ender-3, they do not have native support for a bed leveling probe. The later ones do. That's actually the main reason why I got it. Now, you can install a bed leveling probe like this on the 8-bit boards, but you need to do some sketchy stuff, which includes soldering and flashing a bootloader onto the board by physically connecting an Arduino to it, which is something I don't have. And yeah, it's just a bit sketchy, and I just got a control board that does support it just right away. But we'll get into that a bit later. Then the third and fourth upgrade at the same time are both the extruder. Now, one of those replaces the stock plastic single gear extruder with this metal extruder setup, which is dual geared. You can see there's a gear, and you now have 2 interlocking extruder gears instead of just one and then a guide bearing. So that means we now have more pressure on the filament, and also just because this entire assembly is metal instead of plastic, you know, like there were some reports that the plastic assembly does just sort of break a lot, which is not a problem with this metal one, and it's just overall higher quality. And the other upgrade that came with it is that, well, this upgraded extruder also came with the option to direct mount it, which is why the extruder setup is now directly above the printhead. It used to be over here, where you can see where the extruder setup and mounter used to be, because the stock Ender-3 and also the V2 version used a Bolden extruder setup. They only went to a direct extruder setup with the Ender-3 S1, I think, and now the Ender-3 V3. Those all come with direct extruders, but the original, the Pro, and the V2 and its sub-variants all came with this Bolden extruder, which, as I've said in the previous video, there's nothing wrong in principle with the Bolden extruder. It's just that, like, they have benefits because you don't need to move all of this weight around, which means you can, you know, print faster. But Bolden extruders are they're just harder to work with, and they tend to have overall worse quality, and just there's a couple things that can go wrong with them, which just can't with a direct extruder, like your Bolden tube slipping out. That's not a thing here. It's directly wedged between the extruder and the hot end. There's no bending, no moving going on for the Bolden tube. It is just where it is. So yeah, so stronger dual gear extruder and a mount to direct mount this on top of the printhead, which now means that this is a direct extruder now. And, you know, that means I don't need to retract as much, and just generally the quality is a bit nicer. That, I think, is a pretty nice upgrade. It's not an upgrade you need. A lot of people use the stock Bowden extruder, and again, it's fine, but I just prefer direct extruders. Like you can see, my Ender-3 has one. Also has one. Here's the motor, and you know, here's the gear assembly in that little part, and then below that is the hot end. I just like direct extruders more, and that's why I got it. Then, while I was getting the extruder upgrade, I made sure to also check that I get a new motor with it. You can get the extruder upgrade just with this red assembly right here, or with the motor. And I ticked the with motor option. It was only €5 more expensive, and you know, €5 for a 4240 stepper motor, pretty decent price. And that means I can reuse the stock extruder motor, which is also 4240 motor, on the y-axis. So this right here used to be the extruder motor, and it is now on the y-axis, because the stock y-axis uses a 4234 motor, like this one, on the x-axis. And because the print bed is very large and heavy, and especially when a large print is on it, now this is lightweight PLA, but imagine this was regular PLA, it would be more than twice as heavy. Yeah, the y-axis is usually the weak spot of any bed slinger i3 style 3D printer, and that's why I wanted to put this more powerful motor on it. And I can say, having done a resonance test with Clipper, this bed can now do 3800 millimeters per second squared accelerations. And even with the rather heavy, because it's like pretty much all metal direct extruder setup on the x-axis, this one can still do 5300 millimeters per second squared. For comparison, the stock acceleration limit on the Ender-3 is 500 millimeters per second squared. Now, it doesn't really come close to my Ender-3 which can do 13,700 on the x-axis and 7,600 on the y-axis. You can see the Ender-3 has an even larger y-axis motor. But considering that I thought 3,500, which is slower than any of these, was pretty fast, I'm quite satisfied. So yeah, I just run this. Actually, I think the slicer is set up for 3,500 millimeters per second squared, but I usually just usually just specify y-axis at 3,800, x-axis at 5,300, and it's fine. There is some slight ringing, probably because I need to retune the input shaping, because I did put this new shroud on the extruder, which probably changed how it behaves a bit. But yeah, it's not like I'm seeing any major quality problems. Like some slight ringing, I never had a single layer shift on this printer, so that's good. I was honestly expecting to see a lot of those, but I haven't had a single one yet. So yeah, and like quality-wise, like you can see a bit of a pattern here, but surprisingly enough, that pattern is not ringing because it's very consistent and it's always exactly the same, no matter the speed you run it at. I'm not entirely sure what causes this pattern, but I think I have a good theory. And that is that the control board that I put into this printer actually uses some pretty bad drivers. As you can hear, the printer is rather loud, despite this control board that I bought being originally sold as a silent board. At least that's the box it came in. It could be that I just got the stock board that whoever I bought this from replaced with their silent board. But yeah. The board in here, it has a little C written in Sharpie on the SD card reader, and I saw online that apparently that means my control board uses HR4988 drivers, which are a knockoff of the A4988 drivers, which are the stock drivers of the original Ender-3, so literally the exact same drivers as the stock 8-bit board, and they are loud, as you can hear, and they also don't have interpolation for microstepping. So apparently these still do have 16 microsteps, but for some reason Clipper doesn't seem to use that, or it doesn't seem to be implemented on the board correctly, because all the Creality boards, as far as I know, just use standalone mode and not actually wire the drivers up with their full functionality. So I'm pretty sure that these artifacts actually come from the steppers going in full steps. That is my theory, at least, because I saw a video on Maker's Muse where he also had his stepper motors go in full steps, and it produced some very, very similar looking artifacts in certain places. So that's what I think is happening right here. I think the drivers just go in full steps, which means that potentially I'll have to upgrade the motherboard again. Which, if I do that, I'm probably just going to get a Big Tree Tech SKR Mini E3. Actually, I already have one. So this is a aftermarket Ender-3 printer mainboard. This one specifically is not going to go into this printer. It's going to be used for a different project, but these, I got this one for 40 euros, and you can find a used Ender-3 control board like this one for around 35 to 37. So the price difference is minimal, and this one is guaranteed to come with TMC 2209 stepper drivers, I think, which are much more silent and have interpolation for 256 microsteps. And also the board just has a lot more functionality because it actually wires up the stepper motors in UART mode and not standalone. And just generally, this motherboard does a lot of things that the stock Creality board cannot do for basically like a few euros more. Oh, actually, yeah, it was $40 US, so this was literally the same price in euros as I got this used Creality board for. So yeah, it was $40 US, not 40 euros. So like, it was literally also 37 euros, which is what I paid for the board that's in here right now. So yeah. But where were we originally? So I upgraded the Y-axis motor. That's what I did. Then another upgrade is that the printer now has a second Z-axis assembly, just entire assembly. So it has an extra motor, an extra acme nut, and an extra lead screw. Normally the Ender-3 only comes with the assembly on this left side right here, which means that the right side is only supported by the V-roller wheels, which is, you know, it's better than having a cantilevered printer, but you can very much, on a stock Ender-3, you can just put load on this and you will see the axis visibly move. Which is a bit of a problem, you know, if you move this print head that now has the extra weight of a diode extruder on it at very high speeds, you know, it tends to shake the x-axis a bit, and you get some print inaccuracies. So I got this upgrade to add a second z-axis to the printer, so that now both sides would be supported. And yeah, this upgrade kit came with a wire cable, so you don't need a motherboard that has two z-axis connectors, though this one does have it. The stock one does not. That you need the Y cable for that. And yeah, it's just a dual Z screw setup now, which is exactly what the newer Ender-3 models also do. And that now means that there's basically no shake whatsoever on the x-axis, which is very nice, which means that once I retune the input shaper, I can probably use some even higher accelerations on the x-axis, because now it's a lot more sturdy than it was before. And that necessitated another upgrade, because usually on the stock Ender-3 where this motor now sits the power supply, which, as you can see, has been relegated to sitting below the print bed. And that is where these feet come in. So usually the Ender-3 sits right here on the table, but because this is not enough space to mount the power supply to, I found this set of extension feet on Thingiverse that you can print. You know, you put them in for the front. They use the V-axis, like V extrusions, to just slot in. You just unscrew the bracket and then push them in. Though I have to say that the tolerances were very tight. I had to use a hairdryer to soften the PLA to get these in. So be careful. Or maybe just print them at 99% size if you want to be sure. But yeah, as you can see, the back also has some feet, and it has these little brackets that hold the power supply. It's just screwed in with two screws on the left side. The rest side is just sitting there. And I also printed out these little cable holders, which use a zip tie, and then this little 3D printed part, which uses again a V-slot screw and nut, which I had left over from the Z-axis upgrade kit. It does ship with a bunch of extra screws and V-nuts because it's compatible with a bunch of Ender-3 variants. For some you need those. Not for this one though. So I put the cables here, so that we have the power supply, the main power supply cable, and then the Z-axis cable that goes to the right motor. And I also did the same thing back here. You can see the little part, because the so these are the cables for, you know, the hot end and the X-axis and everything, and these kept coming loose and kept snagging with the bed heating wire, and it would keep like having it behind here, and then when the Y-axis tried to home, the cable would go stiff and the Y-axis motor would start skipping. So that was bad, and probably also not good for the cables. So yeah, I put them in place there to make sure that that doesn't happen again. And then the very last upgrade for now. Actually, I lied because I haven't mentioned the Shroud yet in detail. But yeah, I printed out some fan coverings. So in the front here you have a little fan that cools your motherboard, and in the back here where it says it's kind of covered right now, there where it says Ender on it, that is an exhaust fan from the power supply. And you know, having them mounted like this below the print bed, sometimes you do have failed prints, especially with filament like this, like lightweight PLA. It does string a lot, and when those strings fall off the print bed, they can end up falling into the fans and block them, and you don't want that happening. So I printed out these covers to make sure that no filament, you know, wisps or whatever falls into these fans and can block them. Yeah. And then this upgrade right here, which is a new fan shroud. I kind of really like this design because first up, it actually kind of looks cool. I also printed this one out of lightweight PLA because, well, we already put all of this weight here, so we may as well save some weight down here. But yeah, I like this shroud a lot because it lets you reuse the two stock fans that the stock Ender-3 shroud comes from. So the hot end cooling fan and one of the part cooling fans you can just reuse. And also you only need, yeah, I think you also only need the screws that you get from taking apart the stock shroud to mount this. The only thing you need to buy extra is this second fan, and as you can see, this fan is currently not spinning because the cable is not long enough to reach all the way down to the power supply. I have ordered some extensions, but they are not here yet. So the second fan is currently not spinning. But yeah, I wanted this extra shroud because the cooling on the stock Ender-3 shroud is just really, really bad. Like, it just has this one single fan, and it has an air outlet that's just wide open. You can see this one's a bit more focused towards the nozzle. Oh, I just got bumped by the print bed. So yeah, so the air outlet here is already a bit better, but it's still just this one very tiny fan. And you know, when you print faster, which, you know, all of these upgrades allow me to do, you do need better cooling. And yeah, so I wanted a shroud that gets cooling to the nozzle, you know, from both sides, like again the Ender-5 does. You can see it has these two large cooling ducts that face the nozzle from both sides, because, you know, if you only have cooling on one side, then you're only going to have the benefit of cooling on one side, and everything on the other side is not going to get cooled properly. So I wanted something that has cooling from both sides, lets me reuse all of the stock fans, so I don't need to like buy extra stuff and then have parts that I don't need anymore. Something that preferably looks good, and it was this. So I found this again also on Thingiverse, and this is actually the only 3D printed upgrade that was not printed by the Ender-3 itself, because this was printed by the Ender-5. Because at the time I wasn't sure if this printer would actually be capable of properly printing lightweight PLA. But as you can see, it is. I had some Yeah, I was a bit afraid that the stock hot end, it still has the stock hot end. I have ordered an all-metal hot end, but it was very cheap and it might be very bad. But I will test that out. But yeah, the stock hot end on the Ender-3, it has the PTFE tube, which you can see right here. It goes from the extruder all the way down through the heat break, right up to the nozzle. And this PTFE tube is, well, made out of PTFE. And if PTFE gets hotter than around 240 degrees, it starts to burn and release a lot of very toxic fumes. And I didn't want that happening in my flat. And the problem is lightweight PLA needs to be printed very hot. Like if we take a look right here, 230 degrees. And actually the spool says up to 260, that's way too hot. So I am okay with printing at 230, but not a single degree higher. So it can just about, do lightweight PLA with the settings that I normally use, which is 230. And, the results look decent. But yeah, I was a bit sketched out by having this PTFE tube go all the way up to the nozzle. You really don't want to overheat that. Not only is it going to release toxic fumes, it's also going to completely clog up your hot end, because your filament, your liquid filament, will just go everywhere inside of it. So yeah, that's the thing. That's why this was printed on the Ender-5. But yeah, I kind of really like this shroud, and the red fits, with this extruder setup right here. Though the shade is a little bit different. But I really like it. You can still tell it's a stock Ender-3 from the frame and the fact that it says Ender-3 on it. But yeah, honestly, the Ender-3 stock hot end is very, very not good looking. Like I have it here in a bag somewhere. There it is. It's just this, and then there's this one cooling fan on the side. It does have a bit of charm to it, but I just kind of don't like it. Also, it's metal. It's like this single part without all of the fans is already heavier than the shroud, because it's metal. Yeah, it's just... I like this shroud. Better cooling, looks better, lets you reuse a lot of the original parts. You only need to buy one additional fan and maybe get a couple screws. But yeah, I really like this, and I guess the only thing that's left to talk about now is what's actually going on inside of the electronics box right here with the new printer motherboard. And I'll continue this part of the video once this print is done, which is gonna be in a bit. But yeah, I think I'm gonna do this comparison between what's currently in there, which is a Creality version 422 32-bit board, this SKR Mini E3, and the stock board that came out of the Ender-3 as well, to just kind of give you an idea of, what all of this does. So let's get on to that. Before we continue, I'd like to thank our recurring sponsor, PCBWay. PCBWay offers professional PCB manufacturing and assembly services of all shapes and sizes, whatever you need for your project. You can quickly get a quote by just telling them some basic information about what you need, and if you like what you're seeing, you can upload your design files and go straight ahead to payment, fabrication, and then shipment. And even if you don't need a PCB specific project, you can still find some very good options here, because PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and even injection molding. If any of this sounded interesting to you, then please go ahead and give PCBWay a try. Alright, the printer is now turned off and we can actually take a proper look at the electronics case. So, this right here is the motherboard case, and yeah, quite a lot of wiring in there, and some of it is quite sketchy. I will have to fix some of it later. But yeah, right here we have the brain of the printer, so to say, a Creality version 422 board. This uses a 32-bit STM32 RET6 CPU, and then for the rest of everything. So we've got a micro USB here, a micro SD card reader here. We have our 4 stepper drivers here below these little heat sinks, which according to this C, they are HR4988 drivers. That's what I read online. I can confirm it. These heat sinks are thermo epoxied on, so I'm not gonna remove them. And then down here we have a whole bunch of other connections. So we have 24 volt main power coming in here. And then here are the connections for, the left one is the hot end fan, so that's this fan over here. And then the other 2 are for the heated bed and the hot end heating. Then here, this blue and yellow one is for the 1-part cooling fan, so this one that's hooked up right now. And then the other one that's not connected would go into this empty socket right here. Now that's a bit of a special thing, because you can see the motherboard cooling fan is connected in a bit of a weird way, because the motherboard cooling fan used to be connected to the second socket right here. However, there's a bit of a problem. It might be an issue with the 422 firmware, but basically both of these fans only turn on when you actually have G-code commanding the part cooling fan to turn on. But I want this motherboard cooling fan to always run, because sometimes you do print without a cooling fan, and then I would just have no cooling for the motherboard, which is obviously bad. So what I did is I unplugged it from this socket, therefore having now an extra socket for the second fan I'm getting. And I used these extra cables that I have from Volt Modding, stuck some of them into the socket, and then removed the plastic pieces from the other end and put them together with the hot end cooling fan, which always runs. Like, the hot end cooling fan is always on, even if the hot end is turned off. So that way this fan always runs. It's fairly sketchy, of course. Like, this is, I mean, these are actually in quite well. But yeah, so that's my way of getting a second part cooling fan socket and also having my motherboard cooling on all the time. And then over here we have some more empty sockets. So the first one, this 3-pin one, is for filament runout detection, which is something this printer just doesn't have. But you could plug this in here and then have a little sensor that will tell you, you know, if your spool runs out of filament. Not something I really care about, though. I probably won't add that, since you can just, you know, see if your filament runs out. And if it runs out mid-print, we'll just measure how high it printed and then print out the rest and glue it together. Then these 2 wires are for the end switches. So we have these little switches that, if triggered, tell the printer that, you know, you're at the minimum position. So there's one on the x-axis and there's another one for the y-axis down there, and those connect over here. Then this empty one used to be the Z-limit switch, so there used to also be a limit switch here for the Z-axis, but since we now have the bed leveling probe, we just use that one as our Z-limit switch, so that is now gone. And then we have 2 more connectors for thermistors. So there's one thermistor measuring the temperature of the print bed and another thermistor measuring the temperature of the hot end. Those connect over there. And really everything else then is just the stepper motors. So you can see this colored one is the Z-axis with the Y cable that splits, you know, the one connector into 2 connectors for the second Z-axis motor, and then the rest is, it should be silk screened on the motherboard. So this is the extruder, that's the Z-axis, and then these 2 are the X and Y-axis. And yeah, that is the motherboard essentially. So this is the used version 422 board that I bought. It came in the box for a Creality silent board, but like, as I've already said, this board is very much not silent, and again the CDOS indicated has the HR4988 drivers. So I suppose this board is actually not a silent board. It probably just came in a silent board box, and this is actually just the stock board that someone ripped out of an Ender-3 V2 or something like that. So yeah. And now we can compare it to the other 2 motherboards we have. So this right here is the version 113 board, and this is the stock board that came in the Ender-3. And this has this Atmega 8-bit CPU. So yeah, 8-bit CPU, 32-bit CPU. You can just tell by the amount of pins these chips have that the 32-bit CPU is quite a lot more powerful. And there's also some things on this motherboard that are actually missing. Like, most of the connections are as is. We have our stepper motor connections, we have all the power, we have the axis, limit switches, and thermistors, and we have only one fan connector. We don't have the second one. But most importantly, the one thing missing on this board is something I haven't mentioned yet, and that is this connector down here, with these very, very loose connections. And those are the connections for the bed leveling probe. This board doesn't have that. This board also doesn't have the filament runout 3-pin connector. It just doesn't have it. You can add a bed leveling probe to this board by hijacking some of the cabling for the display right here, which I'm no longer using because I have my Sonic pad over here. But yeah, you would just plug it into the Z-limit switch for the measurement and then power it off of the display connector. That's how you can add a bed leveling probe to this board, but you first need to flash new firmware on it. And because this board doesn't have a bootloader pre-installed, you need to, on this connector, you need to physically connect like something like an Arduino to it, and then first flash a bootloader onto this thing. And then still the implementation is kind of sketchy because you need to hijack the display cable. And then you still only have an 8-bit CPU at the end. So I just decided to just get this board instead. And it just has, it just has native support for the bed leveling probe right here, and then also filament runout detection if I want, and the better CPU, and potentially if I actually got one with the good drivers, it would also be more silent. But yeah, this one uses A4988 drivers, which are essentially the same as the HR4988. They're just knockoffs of each other. But yeah, so this is the stock board. And again, the main reason why I replaced the stock board is that I wanted native support for the bed leveling probe, because I still think it is the most important upgrade that you can do to any 3D printer. It's just, you get automatic bed leveling. It just makes it so much easier. It just gets rid of so many problems. And then we can get over to this. So this is the Big Tree Tech SKR Mini E3 version 3.0. And this is, again, another drop-in replacement for the Ender-3. You can see basically the connections are in the same spot again, but this has extra functionality. This is basically, a high-end replacement for an Ender-3 mainboard, but it will also work on other 3D printers. It just has the connector layout for an Ender-3 to be a simple drop-in replacement. And this does a lot of fancy things. Like just having two Z-axis connectors by itself, so you don't need a Y cable. It has TMC 2209 stepper drivers, so the actually silent ones. It has a pretty substantial heatsink, and not just these small ones that are thermal epoxied on it. And then it has a whole bunch of extra connectors, which I'm not entirely sure which every single one does. It is somewhat labeled. But yeah, a lot of those labels are just kind of cryptic, and you need to look at the datasheet for the motherboard to really figure out what they do. But basically, it has all the connectors that that this board has, and a couple extra ones. Like it should have a couple extra fan connectors still. Like it has that second Z-axis connector. It has connectors for like NeoPixel LEDs, which adds like a LED indicator light to your printer. It has an extra feature like this little reset button. If your printer ever hangs itself, you can reset it like that. And just generally, it has a bunch of extra functionality. One cool thing that this thing can do is actually sensorless homing. So we talked about how the printer has these limit switches, which is one way to tell which position your steppers are in, because like when the printer's turned off, I can just move them around. So how does the printer know where the motors are? Well, it homes them, so it drives them in this direction until the switch is triggered, and then the printer knows exactly where everything is. And, well, you need those limit switches. But what this board can do is, because the stepper drivers on this board are connected in something called UART mode, they have more functionality available to them than on the Creality boards, because the Creality boards use something known as standalone mode. Now, standalone mode means that this board needs no physical modification to fit other stepper drivers, but that disables some of the fancier functionality of those drivers because, well, they only use a very essential level standard mode. Whereas this board actually implements UART mode, which is why this board only comes with TMC2209s, whereas the Creality boards, they can come with TMC2209s, but I didn't get one of those boards. So this board is pretty loud, and this one is basically gonna be the same as my Ender-3 S1, which is basically silent unless you move the motors very, very quickly. But yeah, this uses the stepper drivers in UART mode, which means that they enable some extra functionality. And among that extra functionality is sensorless homing, because the stepper drivers in UART mode can actually sense, or more like report, the current draw of the stepper motor to the CPU. And if you can measure the current draw, well, you just look at it while you move, and if the current draw suddenly goes up by a lot, that means you've hit some sort of block, which, as long as your axis isn't blocked with some debris or anything, is just gonna be your end. So you're gonna be at the 0 position for that axis, so you don't need a limit switch anymore, because you can just tell by the amount of current that the motor is drawing. So that's how sensorless homing works, which is a fancy thing. I don't think I'm gonna use it because, well, this printer already has the limit switches, and just plugging them in is, kind of easy. But this is a thing for people that perhaps buy this motherboard to build their own printer, and they don't want to spend money on limit switches, and they can just use sensorless homing instead. So yeah, that's a bit of a cool thing. And yeah, this replacement board, I paid $40 US, which is about 37 euros. And coincidentally, I also paid 37 euros for this board. This one was used on eBay, and this one was new from the BQ store. So yeah, this one's definitely the better value option, though the one drawback is that because it has this extra functionality, it does require its own firmware. Now, Big Tree Tech does provide the firmware, and I'm gonna flash Clipper on this anyway. I'm not gonna use Marlin. So I'm gonna have to make my own firmware anyway. But yeah, that's a little bit of an extra hurdle. You do need to, if you want to use this motherboard to its full capability, you do have to mess around with making your own firmware, even if you want to use the stock Marlin firmware. But yeah, that's something I'm okay with doing. And now, I guess at the end, yeah, so why did I even have this? So, this Ender-3, I'm actually not gonna keep it. I will give this Ender-3 to my parents, because, well, I do fly my RC planes at my parents' place, because I live in the city, and flying rather large RC planes in the city is a very bad idea. And when I go there with my RC planes, sometimes, we have a hard landing or something breaks. And when that happens, I can just kind of not do anything, because my 3D printer is here in the city. So, I'm going to bring this Ender-3 to my parents' place, and because you've just seen it print lightweight PLA just fine, and it's also printing other stuff just fine. Like, it is a very capable 3D printer now. I'm going to bring this printer to my parents' place, so my parents can do with it what they want, and I can use it to make parts for my RC planes when I'm there. So that's the idea. But I also still very much like the idea of having 2 printers available to me, just because, if one ever breaks, I still have another one, and also if both work, I can just print things twice as fast. And that is where this board comes in, because I have bought another Ender-3, an Ender-3 Pro, actually. It's not here yet, it was sent out last evening, and it will be here hopefully in a couple days. And that is where this board will go into. Now, that Ender-3 Pro already comes with a 32-bit board in it, because the original Pro also came with the 8-bit board. So it is possible that that person actually already put a board like this into that printer, but I assume it's gonna be one of these. So that's why I got this board. And maybe I'm lucky and it's gonna be a Creality board with better drivers, then I'm going to replace this board with the one that comes in the Pro. But if it's the same one, then I guess this Ender-3 is gonna just keep being kinda loud. I don't think my parents will mind, it's just gonna be in the workshop area where no one spends a lot of time. But yeah, that is where this board will go into. So I'm going to do everything I did to this printer again to an Ender-3 Pro. Though not really everything, because that Ender-3 Pro already comes with an upgraded print bed, it already comes with the exact same direct extruder setup, and it actually comes with a genuine BL Touch, not the 3D Touch knockoff. So it already comes with all of that. And then, yeah, the one thing it doesn't come with is the second Z-axis screw. So I already have ordered a kit for upgrading that as well. I also already have ordered a second fan because I'm gonna be attaching the same shroud to it. I actually already have it here. Gonna made it in gray this time. Actually silver. It's like this silverish PLA plus. But yeah, I'm putting that shroud on it with the second fan, and I'm also going to. I also got a second one of these larger stepper motors to upgrade the Y-axis. But yeah, I'm gonna do this again. I'm upgrading another Ender-3, just a Pro, not the original 2018 one, but it's essentially the same machine. Like really everything the Pro does, it uses a different model of power supply. This thing is a 40 by 40 instead of a 40 by 20 millimeter thing, and the electronics case is swapped around so that the motherboard is not on the floor but on the ceiling, and you don't have the problem of this fan being on the top again and sucking in, filament scrap. That's really everything that's different about the Ender-3 Pro. Other than that, it's the same printer, so it's gonna be essentially the same. But yeah, this video is now closing in on 40 minutes long, and I hope this was somewhat educational. I mean, I like explaining things. That's why this channel exists. I like explaining stuff, especially when it comes to building things. And I hope you were entertained by this as well. There's gonna be another video about the Ender-3 Pro when I upgrade it, and then hopefully I'm going to shut up for a while and do some more graphics card stuff. I actually have the test bench set up right here for a project. I do want to make a video about just like running a setup completely at stock and then running it with everything overclocked as much as it will go, and then actually go what do you gain? Because if you gain less than 7%, you're actually not gonna notice it, but it's gonna be more than 7%. I can tell that much already. But yeah, I do want to make a proper data measured in both benchmarks and real games and all that stuff, which is why those hard drives are here, so I have games on them and all that sort of stuff. But that's for a different day. So yes, I would like to say right now, thank you all for watching, and until next time, goodbye.